Let's talk about technology. So one of the most, as I work with technology.
It doesn't work.
Aha!
I think the batteries are dead.
And this one as well, I assume?
No, that was.
Oh, darn it.
Sorry.
Okay, that's okay. So my model is specifically designed to help people to more appropriately integrate technologies into K-12 environments, but as is the case with most models, you can see this being applied in more generalizable contexts. So the first thing that I want to give you background on is why this is important. A lot of K-12 instructors are moving towards using more comprehensive pieces of technology or software in the way that they teach, like Canvas or Google Classroom. And so we already have a rubric, is probably the best word for it, for describing whether or not teachers are doing that well. One of the best ones is the Technology Integration Matrix, or the TIM. And what I have done, yeah, we'll skip to that. So what I've done is I've actually taken the Technology Integration Matrix created by Florida State University about 7 years ago, and I have reverse engineered a model for performing well on this rubric. So in other words, if you know what these particular qualities are, and I'll describe that in a second, then thanks to my model called the Applied Technology Integration Matrix, or the Applied TIM, you should be able to perform well on it. It allows you to integrate technologies in a successful way. And what I love about the TIM, or the TIM specifically, is that it is extremely comprehensive. Here's a look at the breakdown of what this matrix is discussing. There are 5 particular elements, that's what we'll call them, with these 5 different colors, and there are 5 levels of success, 5 successive stages in which you are improving the way that it is utilized. And as an example, if you kind of zoom into this part right here, you could, under active learning, be at that very first level where information is being passively received, or at that second level, all the way down to the very end where you have active transformation in your instruction, which is great, but really, really difficult. And so that's what this technology matrix is supposed to measure. Here are some more examples. You can get a little bit of a zoomed in look at 2 more rows here with authentic learning, goal-directed learning. But my job is not to explain to you the TIM. My job is to explain to you my model. So this is the TIM, the Technology Integration Matrix, and so we're going to convert that into the Applied TIM model. So the purpose of the Applied TIM model is to optimize the efficiency with which instructional designers or teachers can increase or improve the way they integrate technology into their instruction. So you have the same 5 elements that are right here, along with steps that go along each of these branches with 3 different gap checks. So a tech gap, a skill gap, and an incentives gap check. And for those of you who have studied front-end analysis or are currently studying front-end analysis with Dr. Push, you would probably recognize my leaning towards the behavioral engineering model in this system, because I do like having a seemingly comprehensive way to make sure that if there are simple solutions to your problems, you are addressing those first. That's how you optimize the improvements in your system at large. Let's go through this model, take it for a test drive, and see how it actually looks. So the first thing that you do is always to evaluate. This is your benchmarking situation. In a way, you actually just use the TIM to find out where you are performing in the TIM, the Technology Integration Matrix, so that you can find out at what level you are for every one of the 5 elements. So for every single one of those elements, you evaluate where you are. These 5 terms, by the way, are the 5 levels. And I'll show you what that'll look like with an example. After that, the tech gap is frequently the simplest solution to these problems, so we start there. If technology is the true gap, congratulations, you solved it. Maybe it's just buying new light bulbs. Maybe it's something a lot more expensive, but still more simple than a skill gap. Finding out if there is something that our instructors need to be able to understand. That usually takes a lot longer and is frequently more expensive to implement. Finally is probably the most complex to do evaluations or analysis of, which is the incentives gap. And then after that, you find ways to solve them. You would go back to the Technology Integration Matrix, utilize the resources that are directly connected to those 5 elements, and hopefully benchmark changes from your original status to your current status. And the idea should be to move you from the left side of this chart right here to the right side of this chart in as many of those categories as possible. To demonstrate what optimizing the TIM would look like, we're going to give an example of an environment. What's interesting is that an environment of teaching could be one teacher that has one rating for all these 5 elements. It could be a general analysis of 25 teachers or 500 teachers at a university or in a K-12 setting and how they generally use their technology. So no matter what that environment is, let's pretend that, in this case, one teacher, why not, happens to be at this level for all of these. So you've gone through the matrix, you've done the first step of evaluation, and they are excellent at creating authentic learning using technology, but not so good at the constructive or active learning with the use of technology. As a side note, typically these aren't so diverse. Usually if you're good at one, you're good at the others, but let's just pretend for an example here that this is what we've got, because it helps demonstrate how optimization will work. Generally speaking, moving from step 0 to 1 and 1 to 2 takes less effort than moving from 4 to 5. So you should always, for the sake of efficiency, start with your lowest components. There's another reason for this, which I'll explain in a second, but generally speaking, you want to raise your weaknesses before working on your strengths. That's generally how a lot of optimization works. So, based on this teacher situation, we could go back to the model, plug in these numbers. So this is the number of check marks that were in those particular elements, which tells us where should we begin. We should start with both of the ones that have the lowest number. Think of it as first, second, third, fourth. So active and constructive elements. What do? The first thing we do is we focus, isolate those particular elements, and go through the model. What is the tech gap, if there is one? Skill gap, incentives gap. And hopefully, and this is where optimization is really important, if we find out that there is a gap for constructive use, that new technology or a change in the use of technology could improve, we might achieve something called parallel solutions, where a solution that helps with this constructive element could also solve the same problem under active technology. Could also be true for a skill gap or also for an incentives gap. So if you are able to find it, that's why you are saving money and time by utilizing my model, because it actually helps you get a framework for understanding how they relate to one another. So the purpose of this, the outcomes involved, is to create a framework for front-end analysis, as was shown, a framework for optimizing efforts, as was shown with parallel solutions and with the minimization while maximization of outputs. And the eventual goal is pretty simple, to help teachers become successful integrators of educational technology in their classroom, whether it's Canvas or Google Classroom, something that they're forced to use, or, as is my passion, maybe they start exploring and they start trying new pieces of software, because now they know how to achieve the highest levels of technological integration in K-12 settings, and by doing that, you've given them a sense of agency that will presumably save them a lot of time and effort and allow them to focus on what they're really passionate about, which is the student outcomes. So that is the applied TIM model for equipping K-12 environments to integrate instructional technologies. I'm going to put up the main model